yeah, I've got, this one's a line. But is this one a line? Not going to be a line. It's an x squared, y to the first. That was actually, a parabola. Think back, remember that. But, yeah, these are nonlinear systems. So let's see what happens. Don't even really have to realize that. We just want to solve it. And looking at it, what are you thinking as far as solving? Substitution or elimination? Substitution, yeah. Again, we've got the y equals, and so that's going to be really nice for substitution, isn't it? Yeah, let's just, for y, substitute 2x minus 5. So we get 2x squared minus 3 times 2x minus 5 equals 25. Distribute the negative 3. So we have 2x squared minus 6x plus 15 equals 25. Okay. Now what? It's a little different type of equation, isn't it? The others we just solve for x and get x on the side by itself. However, that's not going to be the same here. How do I have to solve this one? Need one side to be 0. Since I have an x squared equation like this, it looks like a factoring problem, isn't it? Oh. Just, again, checking you there. 23. It's Monday. That's how I got that. Okay. 23. Yeah, I need to make one side 0 because this is an x squared equation. So if I make one side 0, subtract the 23, both sides, so I get minus 2x squared minus 6x minus 8 equals 0. Then one thing I note here is I can, all those divide by 2, so let me, if you ever see that, that'll help out tremendously. If you divide everything by 2, we'll get x squared minus 3x minus 4 equals 0. Makes the factoring a whole lot easier, so now I factor my left side. X squared is x and x, minus 4 with minus 3 in the middle. Hey, that's minus 4 and positive 1, isn't it? Set those each equal to 0. Add the 4 and subtract the 1. Move that up here. So get x is 4 and x is negative 1. However, I'm not done because we're solving a system, and in systems I need an x and a y. So in this case, I've got 2 x's, so I need a y for each one of those, don't I? Okay, well, if I go back and, again, looking at the equations here, it looks like it's a whole lot easier to plug in x here than it would be here, so I'm going to plug in y to be, or x to be 4. And so that's 8 minus 5, that's 3. Then do the same thing for x is negative 1, right? 2 times negative 1 minus 5, that's negative 2 minus 5, that's negative 7. So here's what I've got. I've got x is 4, I've got y is 3 then. I've got x is negative 1, I've got y is negative 7. What does that mean? Well, that means I've got 2 solutions to this system. And again, it's because it's the parabola and the line. Those are going to maybe intersect differently. You could get one solution, you could get 2, could get none, like we had before. But in this case, we do get 2 solutions. Is that okay? All right. Let's try another one. How about 3x squared plus 5y squared equals 14. And 2x squared minus 3y squared is a y squared. Yeah. All the variables are squared there. I forgot to put the square on the y. Everything's squared, x squared, y squared, both equations. All right. So first point, how are we going to solve that one? Yeah, this one's more probably set up for elimination. Everything's squared. So I think so. Let's think elimination here. I can do this very same thing with y squared as I do just for regular y to the first. I can eliminate the variables based on that. So what are you thinking? Well, for 2 and 3, I've got the 6. 5 and 3, I've got the 15. But again, it's positive and negative. Let's just go ahead and eliminate the x's. Okay. I'm going to eliminate the x's, the x squareds. And so both of them need to be 6x squared, one a positive 6x squared, the other negative 6x squared. So I'm going to multiply what? The top by 2. So that'll be 6x squared plus 10y squared equals, and don't forget, you have to multiply both sides by 2, so it's 28. Then the bottom I need to be negative 6x squared, so I need to multiply by what? Multiply by negative 3. So that'll be negative 6x squared. Negative 3 times negative 3 is positive 9y squared. And then negative 3 times positive 3 is negative 9. Add them up. The x squareds do eliminate. So I have 19y squared equals 19. Well, divide that by 19 and have y squared equals 1. And yeah, in this case, it is a y squared, but this one is probably, for most of us, we're thinking square root method. Square root both sides. The only catch is what? Plus or minus on that right side. So I get plus or minus y equals plus or minus 1. Okay, well, again, I need an x to go with each one of those. So if y is positive 1, then what about the x? Well, I'd have 3x squared plus 5 times 1 squared equals 14. And that's 3x squared plus 5 equals 14, right? Subtract 5. Get 3x squared equals 9. Yeah, and again, square root method, so divide by 3 there. X squared would be 3. And so x would be square root both sides. Square root of 3, just plus or minus square root of 3. What about negative 1? Well, good news is here, get the same thing, don't I? So if I square negative 1, I get positive 1, so that's still 3x squared plus 5 equals 14. Same thing. All right, well, how many solutions you see there? Well, we could write them all out, but let's write it this way. Since both of them get the same x values, we can just say x is plus or minus square root of 3. The y is plus or minus 1. Meaning, very compact way of writing 4 solutions, isn't it? Because you got square root of 3, positive 1, negative square root of 3, positive 1. Then you've got square root of 3, negative 1, and negative square root of 3, negative. There's 4. Okay. And you can write them nice and neatly like that. Is that okay? All right. Here is another. How about x squared plus y squared equals 45, and x minus y equals 3. Well, I'll just tell you here, elimination is not so good because, well, I've got x squared, and then I just have regular x. I've got y squared, then I've just got regular y. So neither one matches up as far as the powers go. So this is substitution, solve by substitution. And so if I solve by substitution, I need one of the variables by itself on one of the equations. And so it looks like this one. Solve for x, move the y to the other side, add y to both sides. So x is y plus 3, or 3 plus y, either way you want to write that. So there you go, we've got my substitution, right? X is y plus 3. So I can take y plus 3 and substitute it for x back in the other equation. All right, so let's do that. So it's y plus 3, but I got to square it. Plus y squared equals 45. What do I do with that? Well, if I have y plus 3 squared, that's not just squaring the y and squaring the 3, is it? Because y plus 3 squared means y plus 3 twice. You got to full it, yeah. Best way to do it is full it out. Full that out, y and y is y squared. 3 times y is 3y. 3 times y is 3y. 3 and 3 is 9. So I get y squared plus 6y plus 9. That's what y plus 3 squared is. Y squared plus 6y plus 9. Now don't forget the other plus y squared there. That equals 45. So here I have, what, 2y squared. So I got a y squared and a y squared. Plus 6y plus 9 equals 45. What do I do with that? Well, it's another y squared, but it's one that looks like factoring to me, doesn't it for you? So I need one side to be 0. Subtract the 45. So I have 2y squared plus 6y minus 36 equals 0. And again, I'm going to make it a little bit nicer on us here. Those all divide by 2, so let's divide everything by 2. So I get y squared plus 3y minus 18 equals 0. Factor that up. Y and y. 6 and 3. Positive 6 and a negative 3. So that's going to mean y plus 6 equals 0, y equals negative 6. Y minus 3 equals 0, that's y equals positive 3. But again, that's just two half answers. And that does not make the whole. So yeah, we need the x to go with those. Again, you can plug it wherever you want. However, I think right here is the best place to go, isn't it? X equals y plus 3, so just plug that in. Y is negative 6, so that would be x is negative 3, right? And if x is, if y is 3, then x is 3 plus 3, that's 6. So here I just get two answers. Negative 6 for y, so it'll be negative 3, negative 6, and this one would be 6, comma 3. Question or any concern? Did I do that okay? All right. Let's try this one. Y equals 8 minus x squared, and y equals 8 minus 2x. Well, we've seen this type a couple of times already before, so what do you think? Solve by, what do you want to do? Substitute? I think so, yeah. Yeah, because I've got y equals here, so I can substitute it for y up here. 8 minus 2x equals 8 minus x squared. Well, that was a little bit different looking. But it is an x squared equation, so I've got factoring, I've got square root method. What do you think this one is? I believe it's going to be factoring, isn't it? You also got quadratic formula if you have to, but I don't think you'll have to. But yeah, I think this one's factoring, so I need one side 0, and my recommendation is make the x squared positive. And so let's bring these two terms over here to make the right side be 0, just to make that a positive x squared. So it'll be minus 8 both sides, and we're going to add x squared both sides. Now on the left, the 8's do cancel, and those I can't combine, so let's just write it x squared minus 2x, the x squared term first. With me on that? Then, so added x squared, right side 0. How's that one factor? Got a common factor of x, GCF of x, so factor off an x. Set those each equal to 0. X is 0, okay. Add 2, x is 2. Well, I need y's to go with those, so plug in x to be 0 here. Be 8 minus 2 times 0. Yeah, that's y equals 8. 0, 8 solution. Here we've got x is 2, so that would be plug in x to be 2. 8 minus 2 times 2, 8 minus 4. 4? 2, 4 is the solution there. 0, 8, 2, 4. Now, what I wanted to mention on that one is this. Why do I have two solutions there? Since we asked why one solution before, why do I have two solutions? Well, the answer is we can visualize it with the graph, can't we? Because if I graph each one of these, what have I got? Well, this one's a line. What about this one? That's a parabola. Yeah, I've got an x squared. That's a parabola. The y is not squared. So I've got a parabola and a line. So let's think about those. Let's graph them and see. Y equals 8. Let's start with that one. Y equals 8 minus 2x, or I could alternatively think y equals minus 2x plus 8. I want y equals mx plus b. Okay. So m is negative 2, the b is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Negative 2 over 1. So it's rise 2, negative 2, down 2, and then run 1. I'm seeing that is the line. Now, we haven't graphed these in a while, so let's think about that. I might again also want to think, for graphing purposes, minus x squared plus 8 instead of 8 minus x squared. Because there I can tell you a couple of things, or hopefully you can tell me a couple of things too about that. What does minus mean? Opens downward. The plus 8, this is just kind of a shifting sort of deal. The plus 8 means it's, here's x squared, so I reflect it downward. And then 8 plus 8 means move it up 8. So I've got a parabola basically looking like that. What's the vertex? Vertex be 0, 8, wouldn't it? That's another thing we talked about. There's since it starts at 0, 0, and I'm just shifting it up 8, the vertex is 0, 8. So here's my vertex of the parabola. If you want, just get a couple other points there. Could use the points that we've got. Sure. Let me do a couple others. Because I want to make a point about that. Negative 1 and positive 1, just get a couple other points since we know it's a parabola and all that. At negative 1, I'd be what? Negative 1 squared, or minus negative 1 squared plus 8, so that'd be 7. All right? Same thing for positive 1. This is mirror image. It'd also be 7. So I've got negative 1 and positive 1, 7. So there you go. But yes, he's right there. We notice then I do have two points of intersection here, and look where they just so happen to be. This one is 0, 8.